Hello everyone, welcome to the session number 2. We'll wait one more minute and then we'll start. Tell us, did you try to solve homework? Was it hard? Okay, let's begin. Today we will talk about working with data in Pandas. As usual, it's not investment advice. Please consider it as an educational course. Hopefully you all know me. I work for Google for 10 years. I do also write articles for pythonvest.com and I lead this course for the second year. So today we will start from unanswered questions on Slido and address some comments from home assignment number 1. Then we'll talk about system design overview. The main goal of our session today is to create a unified dataset from multiple sources. So we will talk about primary keys, joins, and data validation when you have several tables of clean data. Then we'll talk more about how to work with data in Pandas, and I'll show you a few visualization examples. In particular, we'll discuss data types and manipulation, data cleaning, and enhancing datasets with new features. One big piece of data is technical indicators. As someone said, my code from the last year is not working anymore in TaLib, so it took me some time to find a new solution. And I've shared a new code from 2025 and you should be able to run it. Finally, we'll do a descriptive analysis of the data that we get. And this data as a one unified table can be used as an input for an ML model. So system design overview. Last session we discussed about data sources, and it was just an overview of different data sources that you potentially might want to use. Today I will specify some data sources that I use most often, and I'll show you how to merge all of those data sets into one data frame. Also, please do ask questions and vote for the questions on slido.com. This is particularly important now as our field in home assignment submissions for comments is not working now. Hopefully we'll fix it with Alexei soon. So I used to get a lot of feedback from you from submitted homeworks, and now I have less. So let's see what do we have left from the previous sessions. Okay. How can this course help them combine AI with technical analysis of trading using techniques such as ICT, etc.? So first, I do not use ICT. If I understand correctly, this is a visual analysis of candle charts. It's quite close to technical analysis with similar definitions of patterns on those charts. I think it's possible to have a model that takes many images as an input and generates some predictions as an output. I have seen people using OpenAI, but I have never seen any ML model that has at least, say, 1 million of rows with input images. So if you can build these data sets, feel free to do this. Otherwise, I think it's quite similar to technical indicators that I used as input features in our data set, and it should produce a similar result. Would you require using GPU Google Colab for this course? I wouldn't. I'll try to show less compute intensive models and less ML stuff at this course, and focus more on simulation and producing final results. But if you want to train neural network that has many neurons and many hidden layers, you will probably need GPU just to make it faster. How long are the lecture sessions? It's about 1.5 hours. Will financial modeling covered in the trainings? It is not covered. I think that financial statements are quite important. The thing is that it's quite hard to get them for the long period of time, like 25 years. So you can get those financial reports for the last 4 years for free and build a model that uses only, say, 4 or 5 years of data, and see if it works. But we are not discussing financial modeling in the classic definition, like discounted cash flows and predicting value of a company and stock price. How much time do you think we need to allocate per week for the course? I have a slide on this. Usually it's a lot of time for the first 1-2 lectures, and it will be less later. But please tell me if you spend too much time, and I'll try to make it simpler, but not too simple. I don't have your repo, can you share it? So it's shared almost in every communication that I sent on Telegram and Slack and emails for the slides and code. Please use that link. About the capstone project, can we make future changes in the scope we make at the beginning? We are going to learn interesting things all the way. I do not fully understand the question. We will discuss future growth metrics at the course. I won't include all home assignments, stats or new features or ideas that I have this year to the dataset. Will all previous lectures record again or only selected? So all lectures are recorded and live streams are shared on the channel, and we have a playlist for this year and for previous year. Okay, let's continue with the material. So I don't have many unanswered questions from home assignment number 1. I think all of you are interested in the time spent and total number of submissions. So last year, I think it was about 1,000 people joined to the course, and there were about 200 submissions and 124 shared their time spent on lectures and homework. And as you can see, they spent 2.5 hours on lectures on median, and 4 hours for homework. This year, I do a better job with the lectures, explaining you concepts faster. So people spend about 2 hours, but more time on homework, 6 hours. It's quite a lot. That was one of the reasons why I extended the home assignment deadline for 2 days until end of Wednesday. The other reason is that there was a correction in a problem number 4. So you may need to revise it. You can re-upload the submission, and hopefully you will see some value which is closer to the answers provided. And those of you who started and haven't finished yet, please try to submit anything, even if it is 1, 2, 3 problems. And hopefully we can do better. Now we are about 1,200 people registered, more than 2024. So I would expect more submissions in the next 2 days. Question number 2. Will the course provide a starting boilerplate code to begin with, an initial strategy? Yes, I ran the code. I have a file with the data. I will upload it soon, and I will use it for home assignment number 2, but you can also use it for your projects. Next question. How much data is enough, 1 to 10 years, for comprehensive analysis? I think more data is better. I'll use approximately 25 years of data for daily stats. So if you use hourly stats or every 15-minute stats, you might use less data. But just as a rule of thumb, try to use all data available. Just try to control on the features. That's if you join with some of the macroeconomic features, or say with Bitcoin prices that appeared only 8 years ago, and you have many indicators like that, and you build a project on crypto, you might not have any data for 25 years or even for 10 years. So you need to come up with some different suggestion with less data. Next question. Can we add fundamental analysis to the collab? Of course you can. We have several examples in this session, and hopefully you all learned that earnings dates are very important, and they produce daily changes which are at least 10 times bigger than average daily changes happen with the stock. Please try to embed it if you can. What are the latest research topics on machine learning in the stock market? I do not use any research papers published on machine learning or finance. If you have anything interesting, please share. Okay, now let's switch to the main content. Today we will talk about how you might want to process data from web if you get any scrape data. I didn't realize actually that you already have to do this in question number 4 when you have a file provided with the string values and you need to convert them into numeric types. So many of you already did some kind of processing of the initial data. So then we will look at the daily time series for open, high, low, close, volume data. Usual Yahoo Finance library. It's not always working reliably, but I don't know any other free source that can provide same amount of data at 99% of days. So then we will extend our time series examples with the more macro data. So we covered a few macro stats at the lecture number 1. We will see new stats. Then last year I had the questions about European Union data, and I looked at the EU dataset. I have the same code snippet on the dataset. If you're doing the analysis on European stocks, and particularly if their business is focused on some markets or some country, you might need to get more data from the European Union. Or if you're doing African or Asian countries, you need to find some other sources for the macro data. And then we talk about fundamental ratios. Okay, so this is a first code snippet. I will explain what we have here. Normally, if you do some web scraping like pd.read_html or some other beautiful soup, Selenium, whatever you have, you might get a string object or just an object. You might have a data frame like this, where you don't have data type specified, and you need to convert almost all of the data into data types that you can process. So say if it's a date and we want to calculate lags or shifted stats, you need it of a data type datetime. Or if it's a numeric thing like price or returns, you need to convert it to float, double, integer. So, okay, what you normally do, you try to write a function and that converts an input like a string into something of a manageable data type like a numeric. In rare cases, when you have a perfectly formatted string without any other literals, you might do it just in one call, but oftentimes you need to do some regular expressions or some matching for the fields, so that you need to write a function that gets you a numeric value. Then you want to analyze whether there are some errors produced. So you can just ignore those errors. You can remove the data with errors, or you can try to fill the data with the latest available stats. Next, we try to apply vectorized transformations for data processing. That means that we don't want to iterate data frame row by row when possible. So we want to define new columns or transformations of existing columns for the whole vector. And when you do all of this, you have a perfectly formatted data frame. You can do some exploratory analysis, minimum, maximum, average, just to see and what you get and have some sentiment of the data. Okay, let's look what do we have here. So IPO data. IPO data, you can get this data from the website stockanalysis.com. Usually it's a good source of the new data because we want to find some new companies, some expected IPOs, and there are few IPOs, few big IPOs that are expected this year. So I show you how to convert initial data into a data frame. So I have 3 endpoints. I download all IPOs for 2023, 2024, and 2025. I join this into one data frame, and within this data frame I have more observations, and later I try to do something with every field. Say IPO dates, I convert it to datetime, or if it's something which has a minus as an IPO price, it's not a valid symbol, and I try to substitute it for another symbol when I'm reading this as a data as a numeric data column, etc., etc. So in the end, you have this data frame, which is much easier to analyze. And you will have one home assignment on a similar task to do the scraping and convert stats into a proper data frame. So next, as you might have seen, we work a lot with time series, and I suggest you try to read the Getting Started tutorial or comprehensive guide to time series. I used Pandas for years, but I read those articles only last year. When you're working with time series, what things you might want to think about? First is how you get that time series, whether you read it from string value or you want to extract some specific things like hour of the day or a date or a time zone. And usually just using to underscore datetime function is enough for me to convert some string value to a time value. Then there are some libraries with date-related functions. Say you want to define some interval. What were the trades in the last week or months? And you might want to calculate time delta between two different dates. And you can do this, I think, natively in Pandas, but also there are other libraries on this. Next, as with any other data column, you might need to work with missing values, especially if data is a primary key. You don't want to see any missing values, and you need to know exactly when it happened. But maybe you have some other date column which is not primary key, and you can submit some data to those fields if they're missing, because our goal is that all numeric columns are filled 100%. Otherwise, if you feed them into the neural network, it just won't work and it won't compute you any predicted value. Some machine learning methods are resistant to this, like decision trees. I think they can just ignore records without field values, or somehow used other features that are filled to predict. but not all methods are like this. So we try to have 100% filled data frame. Next, sometimes there might be some errors in your conversion of the original data frame, and if it's just 1% of the data and you don't want to spend too much time on errors, you can just ignore them. And finally, there are specific commands defined on time series, and the most important thing is a shift command that provides you to shift the whole vector on 1, 2, or any number of observations, and define new columns, which is a shifted one. So based on this method, we define returns or percentage change. So this is used in every lecture. Okay, more macro indicators. The idea here is exactly the same. So we can look at the code snippet number 3. We have some ticker or some name for the time series, whether it is VIX or it is gold spot prices or Brent oil. Normally we download the data, we check this data in a data frame, and we show some visualization. What happened last year, and how do we extend the data that we currently have? First, last module, we didn't discuss much the indicator called VIX. So it's a volatility metric for S&P 500, and oftentimes it is called as a fear sentiment of the market. And when the volatility is high, that means that big price changes are happening right now. And you can see that there was a spike in the end of actually in the beginning of 2025, and now VIX is going down. So for you it may mean that there are different market regimes when everyone is panicking, when they think that we need to hedge our positions, we need to do something because our stocks or other assets are losing value or quickly gaining value, or some stable regime for the market when there are no big news and small increments every day. So we add a few other important assets to the data set. And first of all, it's gold. It can be a silver or any other metal, or several examples of one asset class. The important thing is that we live in a one big world, and markets are interconnected. So if you are trying to model crypto or stocks for one country, you can't do it only by using features from that particular market. So you might want to add some other global markets and other stock exchanges. So for gold, for example, gold as a safe haven asset was growing, and it is still growing in 2025. So it reached new heights, and maybe it means something for other markets, that people redistribute their assets into gold just because they fear uncertainty. For Brent oil, the situation is quite different. It's consistently declining. For BTC USD, you can see that there are ups and downs, especially in the last 1 year. But currently, Bitcoin reached all-time high. So next, I'd like to discuss one macro indicators from the European Union. So it is ECB, European Central Bank, and how this central bank defines the yield curve. So we discussed Fed rates and treasury bills for the US. So some rates, some rate curve for the US. This is a similar example for the European Union, and you may see in the code snippet for how you want to work with this data set. It has many other metrics. I suggest you click the link and check what you can see on the web. If you compare those rates, so it's exactly the same yield curve for 2024 and 2025, you can see that in 1 year it's a completely different picture. Last year in 2024, people or banks or entities, they were even more uncertain, and they wanted short money, so they were ready to pay more than 3.6% for debt instruments for short term. And only after 5 years you can see that there was an increased premium for a longer term instruments. So that's sometimes called inverted rate curve, and sometimes people say that it's an indication of a recession or some market turbulence upcoming, or expectation of a market turbulence. This year we see a different picture, and it's much better in my opinion. It's a regular yield curve when you pay more when you buy or sell debt instrument for more maturity. So next we have fundamental indicators and the traditional ratio analysis. So what do I mean here? You saw a file home assignment number 1_Amazon. It had earnings dates for the last 25 years. The thing is that it's not easy to scrape it from the website, and if you look, if you use the Yahoo Finance library, you might have stats only for the last 4 years or even less. But for us, it's very important because of the field data of the EPS estimate, reported, and surprise. That's the expectation. Was the expectation beat it or not? And for the dates in the future. So if I were you, I would generate the field. How many days do you have before the next earnings date? And close to the earnings date, you usually see more activity, like more volume of trade, and price can go up or down based on the expectations. And just after the earnings date, it may go up or down based on the reported stats. But you can generate many financial metrics or ratios or other features from the reported documents, balance sheet and profit and loss statement. And here are the example, like growth of revenue, net income, profit margin, EBITDA, price on equity, price on book value, debt on equity, and more. And here you see Walmart that last 3 years stats are getting better and better in terms of margins for Walmart. It should reflect better prices for the stock. And the question is whether those expectations or those numbers are already priced into the stock value or not. So it's up to you whether you do classic fundamental analysis and build a fair value of a stock based on its financial stats, or you just generate many new fields that are based on the financial reporting, and then check on an ML model of your choice whether these metrics are important. So we don't look at all code snippets just to save time, and they are, frankly speaking, they are not very hard to replicate. You can all check those code snippets later. So now we are moving to the next section, how we create a unified dataset. Before that, I want you to show one graph. It's called candlestick chart, and it's just a visualization of an open, high, low, close volume data that we all use from Yahoo Finance. I built a wrapper on the data. I actually read it from some Medium article, and I built a wrapper function. So if you want to do a brief visual analysis of any time series, I suggest you try using that code snippet, and you will have this graph, and you will be able, let's see, code snippet number 6. You'll be able to play with it. That's a dynamic visualization, even though that's the notebook is already computed. So if you open it in Google Colab, it may not possible to do in on GitHub. So you will need to open a notebook from GitHub. So you just press GitHub and submit the link. It will open this in Google Colab, and then you'll be able to run it and play with it. Let's move on. Let's assume that you have this data on a favorite assets type that you want to build a strategy on. So how do we build a trading strategy? And this is the same strategy that we discussed last year. It's considered to be one of the simplest strategies because it uses just two features to work with. You can extend the strategy. You can build a new strategy based on SMA 50 or SMA 100. So SMA is simple moving average 10 days, SMA 10, and SMA 20 is simple moving average 20 days. So similar idea, it can be simple moving average 50 days. And you can try to simulate it and see whether longer time span works better for you. But the idea is as following. SMA 10 is an average for the close price or open price for the last 10 days. And the main feature of SMA 10 is that it is more sensitive to the recent changes of the price than SMA 20. So let's look at this chart, and we see that when some stock starts to grow quickly, SMA 10 will grow faster than SMA 20. And at some moment after a dip, it will intersect SMA 20. That's your signal where you want to buy. So maybe if you define SMA 5, you may get this earlier, but it will be more noise. I don't claim that this is an ideal strategy. It's just for you to understand that we use a number of metrics or features to build on and define some strategy. And in this particular example, we define some simple strategy. With an ML model, you will have a more complicated strategy. So when green line intersects red line, we buy. When you see the growth, and when the growth is finished and now you see the decline again, the red line will be still high because it has stats for the last 20 days, but the green line, if you see a rapid decline in the last few days, it will start to drop immediately, and at some moment it will cross the red line again. That's a signal where you might want to sell. So again, you might want to define like a shoulders or a maximum or some other way to understand whether it was a local or global maximum, and to sell earlier just to capture more revenue. But that's an example of a strategy that you build those rules, and then you can calculate the simulated financial result, not just from what you read in one article or one video. You can simulate for many stocks and for the long time period, and make your own independent data-driven decisions, whether you want to use this strategy or not. Okay, let's return back to our code, and the setup is the same that I had last year, and this year it may be even more important to have a multi-country setup from the very beginning, because from homework number 1, you might have learned that this year to date, many stock markets, they were growing faster than American stock market. And for you, that means that if you were investing in other stock markets, you might have seen no decline at all or plus 10% growth just year to date. But my second point or alternative question was that, okay, if you compare not year-to-date data, but 3 years, 5 years, 10 years, how many stock markets still beat American market? And over 10 years, I think it was just one market that has approximately same growth rate. So for our data set of initial data set for 33 stocks, 11 stocks from American, 11 stocks from the European Union, 11 stocks from India, you might want to extend it to 100 stocks, to 1,000 stocks, whatever you can consume. So there are some limitations on Yahoo Finance, and I think you can't do more than 4,000 calls in an hour-ish. And also you have another limitation for pandas, because we do in-memory calculations, even vectorized calculations. You need a lot of memory and compute speed to do it quickly. So if you have your data set, say more than 5 million of records, it may be hard to compute it efficiently. But you can try to do that in parallel and get some results. Here, what you have for code snippet number 7, you will see that it's about 230K of data for 33 stocks. There are already some metrics defined, like ticker or a company, then what's the weekday. So this is a derived feature based on the date. Say we know that on Fridays and on Mondays there is a weekday seasonality. Then I define historical growth in 1 day, 7 days, 3 days, or it can be any other number of days. And I think I will change this this year to include more stats for 60 days, 120 days, because I want to predict not just 1 week ahead for the next 5 trading days, but I want to predict for 30 days in the future. So you might want to think about this as following. You have one record of data, and using all features available in this one record, you want to predict something that will happen in the future. So in this case, it's is positive growth 30-day future. And this is just one initial data set. It has a primary key. So here you can see that it's a date and the ticker. If you do everything for one asset like Bitcoin, you might have just date. Then I define some classes of features. In this case, I want to define 2 features. One is growth future 30 days. So if I do a regression, I want to predict the future growth for the next 30 days. It's approximately 30 days. It's not 1 month because you have maybe around 18 trading days per month. So we are predicting with these stats growth that will happen with the stock in the next 2 months. And another field is positive growth 30-day future. So for a binary model, I want to have a few classes. Usually it's just 2 classes with positive and negative growth. Then almost all features should be numerical features, and they can be numerical by itself from your original APIs, or it can be transformed features, like you can take a logarithm of volume, you can calculate a lot of growth factors, SMA 10 and 20 stats that we got from the previous example. Essentially, you can define any function on the currently available data and build on that function. Then there are some features that are called categorical features. Say it's a weekday. It has a few values for that feature, and we need to transform categorical features into numerical. That's why we are generating dummy variables for each value. Say whether today is a Monday, we will generate a binary value 0 or 1. Today is a Tuesday, today is a Wednesday, or sometimes you want to produce binned variables. That means that's say volume is a numeric variable from 0 to 100 billion. So the range of this variable is very big. Or a logarithm volume, and the range will be still big, between 0 and 10, but you want to define special segments of this variable. So that's why you're creating bins, and you're converting a numerical variable into a categorical variable, say where the volume is less than 1 million, less than 100 million, and more than 100 million. And this may help your ML models to catch the importance of a variable faster. So if you see from your ML, from your initial ML model, that some variable is important, you can try to define more derived variables based on that variable. So that's the idea. Okay, let's see what we have here. Code snippet number 7. You can see that I define 3 lists of stocks. I have one combined list of tickers. Then I download stats from Yahoo Finance, and I had to change the download methods everywhere in my notebooks, because from this year Yahoo Finance.download produces index as a tuple and not as one simple value. So you need to drop one level of index just to work efficiently with the data, or you can just use another way of downloading stats from Yahoo Finance. That's what I'm doing here, and it gives me a good plain data frame with a few columns defined. Of course, I need to define some additional fields, like I need to know what ticker do I currently see, what is the year, month, week, date, and this is an important thing, how you generate historical growth. And if you haven't seen this before, or you haven't worked with the vectorized calculations, I suggest you spend some time trying to understand what are we doing here. So we are defining 5 more features: historical growth for 1 day, 3, 7, 30, 90, and 365. You can define any number of features of growth here, or different values, and I think they will be still important. Usually some recent values are more important than previous, but you never know. So you can see which features are important only when you already built a model, you trained it, and you can explain the model and see the most important features. So then there are some additional stats, like average 10 days close price, and here you can see another vectorized calculation, rolling stats for 10 days and mean, or rolling stats for 20 days. And here we define a volatility of prices, again with the 30-day rolling stats multiplied on standard so it's a standard deviation of rolling stats, and multiplied on square root from 252. That's exactly number of trading days, and you can read why we define volatility in this specific way. So okay, when we have this data frame, that's the initial data frame to join with for the next steps. Before we join with other data sets, we'd like to see what we want to predict. And this is one stock example, and it was quite similar for many large stocks last year, 2024, that everything was growing. This year you can see that there is a correction. The main idea is that what you see here from a statistical perspective or from the data analysis perspective, it's a time series data, and it is not stationary, because it can be always growing or heavily fluctuating from its average value. So for us, if you have a 25 years of data, it will mean that you train a model on previous 20 years, and that model never saw the value of NVO stock price, which is more than, say, 30. And now, in the recent years, you see that it's growing to 140. And that means that previously trained model can't predict your currently observed values for the stock. So we want to do something, and there are different approaches. Like, you can predict the difference between two observations, or you can predict the returns, and that's what we want to do here. And that's the right picture. And you can define returns as a percentage change, or just a change of the last value, or divided on the previous value. And here you see two distributions. One distribution is for one or 1 day change, and you can see that it's a very narrow bell with a mean and median around 1. So this is less than 0.1% difference from 100%. And if you get the 30 days returns for the same stock, it's a wider distribution, wider bell, and it is biased. The average return is 2% in 30 days, just because this company was growing for many years, and the expected growth is 2% over the time span of 25 years. So that's we need to do before we run any model. Just we need to look at the existing values of a variable that you want to predict, how you split this variable onto train, test, and validation data sets, and ideally those data sets they should have a same support intervals for the variable. So in this case, we don't want to predict absolute values for the stock. We want to predict the returns, and that means that if you know the returns for the next 5 days, 30 days, you can make multiple predictions, and the last current stock price, you can apply that prediction on the last available stock price, and you will see the absolute value for the stock in the future predicted by your model, but you're not predicting it straight away. So you add one step to define. Again, if you try to build a model of a specific time, and in our case, we want to predict whether it's a positive growth or negative growth, only two classes. You want to understand whether these classes are balanced or not. If they are too balanced, say for one day, they are 49 versus 51%, and in many cases, one day growth can be very close to 0%. So it can be essentially white noise, and it's impossible to predict this white noise, and that's why you say, I want to predict whether the growth of a stock was not positive or negative, but was more than 1% or 2% or less. So, and in this case, it may be better for you, and you might get better results for the prediction. If you want to predict 30 days growth, you can see that here you will have two classes which are less balanced, 38% and 62%. But what I want to say is that it's both cases are fine, and you just may want to transform a little bit a variable of an outcome. The worst case is when you have two classes and one class is 1% or 3% of observations and another class is 97% of observations. And if you have positive growth, which happens only in 3% of cases, and you want to predict that positive growth from a class of 3% of cases, it can be very, very hard to do that. So we want to see, for a binary model, classes that are relatively balanced. Okay, this is an important snippet. Hopefully you all can execute the code that I provided, and it will work for you in Google Colab, or whether you run it locally. If it's not working, let me know. Try to Google it. Every year something is changing, and the story is that there is a library called TaLib, and it is an old C language library. There are wrappers in Python, and those wrappers libraries, they use specific dependencies. Say NumPy library should be of a specific version, otherwise it won't work. Or sometimes you can't even use that wrapper straight away. You need to compile that C code, and only then you can use it. I don't know why there is no good Python library. It's possible to write all of that manually. It just I didn't see any other library that can produce all technical indicators at once. And here you will see that our data set will grow considerably. So it's again 220 to 130 K of data, and it was just 37 megabytes, and now it will be 190 megabytes of data, because on top of the existing 25 columns, you will produce another 120 columns of different technical indicators and patterns. And I will show you here. So code snippet number 8. There are links. I have an article and I have a code. You probably need to substitute some initial installs, but there you will see that I try to use all available functions in that library, and that's specifically function classes that I try to use there. All groups of indicators. I think in this notebook I just use a subset of these indicators. So that was a 2023 code which was working and now it is not working. This is a 2025 and there is a link where you can read the details. So it was working for me. I define 3 functions. First function generates all momentum indicators for one ticker. So I have a data frame which is a subset of my bigger data frame for just one ticker, one stock, and I generate a lot of additional features based on that one time series, and those functions, they may have other parameters as well. So you can define even more technical indicators or your favorite technical indicators. So here I just use the standard calls that are suggested in the repository. Then there is another function for volume, volatility cycle, and price indicators. That's another maybe 10 indicators, and then one function to generate many pattern indicators. So you can see that additionally you can get like 60 pattern indicators. And finally, when I have all those functions defined, I run them in a cycle and I add new features to the original data frame with 25 columns. So you can see from here then that after I run all those functions, I do the merge operation on some primary key, and I use a validation. That's the thing that I use everywhere. If you're an analyst, you work with SQL, with databases, you can often combine stats from different data sets and you can join them on left, right, or inner join, and you want to control whether it is one-to-one join, one-to-many, many-to-one, so there is no duplication of the data. So I want to see that in the end I have exactly same number of records, 230,000, but number of columns is different. So that's what you get after 145 columns and 199 megabytes of data. And bear with me, I have just one last step with a lot of data frames that are defined earlier or discussed earlier. And after this initial data frame with indicators, I just add 1, 2, 5, or 10 features from each data frame to the unified data set. And here you can see that there are many steps from M2 to M16, approximately 16 steps. We start from the basic daily stats, open, high, low, close, volume data, 37 megabytes of data. Then we add technical indicators. Now it will be about 200 megabytes of data. Then we add other macro indicators, and it's not very efficient because we need to copy stats that are updated maybe once in a quarter or once in a month, but you're copying them many times. And on top of those 144 columns, we are generating another 60 columns, and that will bring us another 100 megabytes of data. And every time I have some other data frame to join with, and a current data frame with all features, I join on some algorithm like left, right, inner, outer. Usually in this case it's a left join. I join on primary key, whether it is just a date or date and a ticker if it's some metric defined or for a specific stock. Then I do a validation. Okay, let's look what do we have here for the code snippet number 9. So we start from a data frame with technical indicators to 130K. We add DAX index, so it's a German stock market index. In this case, it's just one of the indexes. I would advise you to use all 10 indexes that we used from the homework, just to have a better representation of what's happening in the whole world. But here I only join with the DAX, and I show not the absolute value of an index, but what was the growth in 1 day, 3 days, 7, 30, 90, and 365. One thing to consider is that it won't work if you don't remove time zone. For us, we do not use any of a time zone information. It's just one record per day, but because we defined the datetime in such a way, or because it automatically was defined or produced by an API within this format, it can think that this date has a time zone, and when you join two data frames with different time zones, you don't know how to join. You might need to convert one time zone to another. So that's why we just say it's a daily data, remove a time zone, and only after that operation it will join without any problems. So you see that here some stats defined. I look what data do I have here, that there are no null values, and check that when I join I'm filling null values, or I always have a consistent data frame with all stats filled. And now you can see that it's 151 columns instead of 144. Then I add S&P 500 data frame, same growth stats. I defined a function that says growth and underscore which index is that. So I could produce 10 different indexes and it will be all different columns. Just later, when you do the prediction, you want to see what columns are more important than others. This is Dow Jones, another American stock market index. This is EPI, it's an ETF for an Indian market. Then M5. This is an example when you can't join just on the date, because some data can be updated weekly or monthly or quarterly, and your current date is just say 2nd of June, but your closest date is defined only for the 1st of June. That's why I'm defining a new field which is called a quarter, and it will show me date for the quarter start or quarter end, so that I can join with some quarterly updated data so that I can join my current data set, which is a daily one with the quarterly updated stats. And next we joined with the GDP growth, quarter on quarter and year on year growth, etc. So you can see that sometimes I could identify that say CPI stats are not updated for the last month, even though last month is already over, and I need to come up with some solution. So first I need to notice that, and second, I just say I still need those records, and let's assume that the last months of the data is exactly the same with the previously defined stats. Or you can define any else, like an average field or something. I just want to have that data in my final data frame, so that when I run the prediction, I can predict the growth stats even for the latest records, so that I can use it for my real trading strategy when we build the overall ML model and simulate it. So I scroll it down, there is nothing new, just more data frames to join. And finally, we have M16, which is 301 megabytes of data and 203 features. That's a solid data set. I downloaded the file. I will upload it to a drive and share with all of you. In case you can't replicate it, you can use that file to do some analysis for your models and as a starter boiler code to generate for your capstone projects. And as you might have learned, that everything that we discuss here, you better start doing early, because you may need a lot of time to do this. As a recap, what we've learned today. First, we discussed how to work with the web scrape data, how you need to define columns and of a particular data types. Then we downloaded data from Yahoo Finance for 33 stocks, usual daily data for your models. And I also added a link to an article for crypto. It uses hourly data, or you can do even, I think, every 15 minutes, maybe even 1 minute data, or even less. So you can go crazy if you build something very technical analysis driven or intraday tradings. In my case, last year I actually built a model that was very close to what I presented, and it was predicted for 1 week in advance. So it was intraday trading, and I used that model, but and it was growing and delivering results for the first few months. But then when there were market turbulences, my stop losses worked, and eventually I finished with a near zero result, because my trades were stopped. So this time I want to extend the period for 30 days. So logically, I may need more macro data to predict what will happen in 1-2 months. And say you asked questions about tariffs, so maybe I need to add some new features on tariffs, or maybe I need to add new data points for 200 days growth, 250 days growth, or some other microstats. So anyway, we discussed more macro examples, fundamental indicators or metrics that you can get. There are just 4 function calls, and we didn't discuss this in details. You can check it later. Then technical indicators. In most of the models, these features are quite important, and we produced 120 features, new technical features, and then we merged all together. Okay, homework number 2. It is not published yet. We extended homework number 1 for 2 days, and I spent too much time trying to debug and check what's going on. And if you have seen our discussions on Slack, I actually solved one last question with GenAI, and that was my mistake. That originally it boosted my productivity and I could solve it in just maybe 2 hours, but then I spent another 5 hours trying to debug and understand why it produces wrong result. So I suggest, if you can, use GenAI, but try to check everything. I will publish a new homework in a few days, hopefully on Wednesday. Just follow the announcements on Telegram, Slack, and emails. Probably I will do easier homeworks. I want you to spend less time, not 4 or 6 hours, but maybe say 2 hours or for the lectures and 2 hours on a home assignment. I didn't see many posts on LinkedIn or Twitter or any other mediums. Please share this course with others, and you can get extra points for that. You can attach 3 links to the medium while you submit your homework, and this is like you solved another average complexity problem, so that others can see or just be active for this YouTube video. Add your comments, what you like, what you don't like, what works for you. That's there is some discussion, and it's not just a live stream where I speak alone, but there is some conversation. And one last point is that our FAQ is empty as of now. Please, if you asked something or you had some problem and you solved it, just add that solution to the document. You can compare that data engineering FAQ from datatalks.club. It has many questions answered, and I think that many of the questions will appear again and again. So it's important for everyone that you share the most common problems. I can do better work and specify better all home assignments. And of course, you can get an additional point for sharing additional FAQ question. So thanks everyone, and see you soon. Approximately in 2 weeks there will be another stream, and home assignment number 2 will be published in a few days, hopefully on Thursday. See you.